Hello everyone. In this section of the course, we are going to discuss about one of the most important libraries, which is Pandas. Pandas is going to help us perform this data cleaning, data manipulation, as well as data pre-processing activities, which forms the prerequisite for any machine learning model that you are going to create in order to solve any business problem that's provided to you. So all what you'll be provided with is a raw data. So you cannot input the raw data as is to the ML model. There has to be a lot of process that has to be done, like data cleaning, missing value imputation, encoding all the categorical features into numeric, so on and so forth. There are n number of pre-processing activities that are to be done before you input the data to the model. So all of these data cleaning and data pre-processing activities are actually fostered with the help of a library called as Pandas. Without any further ado, let's get to understanding in what ways Pandas is going to help us. So in 2008 at AQR Capital, Wes McKinney and team has founded or created this library called as Pandas. Back then in 2008, Wes McKinney and team basically have found the necessity of creating a comprehensive library that could handle all kinds of data manipulation tasks encountered in quantitative finance. The AQR Capital is a financial firm wherein they actually wanted to create their own library, which basically would help them perform thorough exploratory data analysis or probably help them in dealing with the structured data. So NumPy and SciPy, as you know, these two are different libraries that can help in numerical computations. Right? They are foundational libraries for numerical and scientific computing, but they truly lack the functionality that's required to work with labeled and structured data, and hence they created this Pandas. So Pandas is going to help us work with the structured data. You know the types of data, right? So there are different types of data like structured, unstructured, and semi-structured data. So we have not dealt with each one of these yet. So structured data we already have dealt with during our SQL sessions. That is the tabular data that we expect to have for any of the supervised machine learning models that you are going to create. Let's not worry about all of these terminologies that I'm currently getting you introduced to. Okay, cool. So the structured data, as you know, will be present in this particular format. So you have the data being represented in a tabular fashion like you are currently observing. There are different columns that are available to you like customer ID, gender, age, annual income, so on and so forth till family size. So these are different columns that are part of your structured data. And we also observe different observations or different rows here. I'm calling a row or a record as an observation here. Okay. Each one of these row or an observation does represent a particular customer with a given customer ID. So customer ID is a key for a particular customer. So there are n total observations that you can find, that is indicating that there are n different customer IDs that are present in your data. So each customer ID has got different attributes like gender, age, annual income, spending score, profession, and so on. Any given item or any given cell value here corresponds to a given customer for a particular attribute, describing a particular attribute. For example, the cell value that I have encircled now does indicate the annual income for customer ID 8. And whatever I'm encircling now does indicate the profession of the customer with customer ID 6 and the gender being female. So this is how you need to interpret the structured data. Most of you are already aware of it. So when you try to read this data using CSV reader, we understood that the data has been read like list of lists. So we basically have an outer list and we have multiple inner lists like I'm currently representing, and there will be as many number of inner lists as the number of observations that we are having. So every inner list will correspond to a particular customer ID. Let me call them as row index 0. So this is row index 0. The first inner list is row index 0, which corresponds to the row index 0, that the observation that I'm currently highlighting. The second one corresponds to row index 1, row index 2, and so on till row index n minus 1, considering n as the total number of observations that are present within your data. Right? Now you have these different items that are present within every single inner list. So every item does correspond to an attribute value here. So this corresponds to gender, which will comprise of the value of male, since this first one corresponds to row index 0. So this will have a value of 19. This will have a value of 15,000 and so on. So every item here does correspond to a given column that's present here within the data. So that's how you need to interpret. Let's say that if you want to add a new column here or a new item here, so you might want to write a cumbersome code in order to add this new item in every single inner list here. You might end up writing a complex logic which will help you to add this additional item within every given inner list. So has to maintain the consistency. The given column has to be added across for every single customer that's defined here. For you to actually write some cumbersome logic or fuzzy logic, rather than doing that, you can leverage an existing library like Pandas in order to add a new column. Let's say that the complete data is being represented by an object called df. Df here refers to data frame. So data frame is one of the objects specific to, or we can say the data frame is one of the data structures pertinent to Pandas. Okay, so let me call this as df. Let me call this complete data as df, and I am trying to create a new variable or new column called ai underscore age underscore ratio. So ai here indicates annual income. Okay, so this is nothing but the annual income of a given customer divided by the age of a given customer, right? So this is applicable for all the given customers that are present within your data. So this is a simple statement that I have implemented, which lets me create a new column, compute the ratio of annual income and age for every given observation. So it considers, for the first observation, it considers 15K divided by age 19. And for the second observation, it will consider 35K divided by 21. And the resultant value is stored here. So likewise, you just compute this value for all of the rows that are present within the data here. So this is a simple statement. So I am just trying to reference the individual columns by using a subscript notation, provide the column name here within single quotes. Just do a regular division operation, reference the other variable that I'm planning to have in the denominator. This gives me the ratio, which I can assign it to a new variable altogether. This helps me create a new variable altogether. So this is how easy it is for us to create or add new columns to your existing data using Pandas. So Pandas not only lets you create or engineer new features, it's also helping you in order to do a thorough data analysis, which is a primary purpose of Wes McKinney's team, which helped them create this particular library. So this is actually built on NumPy. You know, NumPy enables faster computation, as we have learned about it multiple times. So since Pandas is again built on top of NumPy, we know whatever computations that we do using Pandas, associated methods and functions, the computations are generally faster in nature. So it can be used for data analysis, and it's also a very comprehensive library that there are multiple data structures, and for every object pertinent to a data structure that you create, you'll be exposed to multiple methods which you can leverage to do so many data cleaning and data pre-processing activities. It's very comprehensive in nature. You might always want to reference documentation in order to understand what a particular method associated to a given object does mean. Okay, it also helps you in data visualization activities, like it will act as a tool for data visualization, which help you generate visualizations for a given aggregated data or a given data that you are observing in the raw data itself. Instead of using Pandas for data visualization, we're also going to use other powerful data visualization tools or libraries like Matplotlib and Seaborn in one of our future sessions. But in this particular module, we are actually going to discuss on how you can generate visualizations of plots using Pandas also. Okay. But these are the three broad features that one can easily perceive by using Pandas library. That is data analysis. It helps you create extensive data analysis. It's very comprehensive. It has got wide array of methods and functions with which you can do multiple data cleaning and data pre-processing activities. It's also helpful in doing a quick data visualization. But I did mention to you that we'll actually go through few other tools and libraries like Matplotlib and Seaborn in our upcoming sessions to extensively look at data visualization as a separate entity. Since we have pretty much understood about Pandas and how Pandas is going to help us read this structured data and also perform the necessary feature engineering activities or data cleaning or data pre-processing activities, all of that, it will also help you in deriving certain aggregation summary, or probably if you would want to understand what is a mean annual income of gender, you just do a group by gender and try to compute the mean value of annual income so that you can understand what is the mean annual income for male versus what is the mean annual income for female. Such type of statistics also you can extract from certain specific methods that you might implement by using data structures pertinent to Pandas. So there are primarily two different data structures that I would want to discuss with you in the upcoming sessions, one of which is data frames. The other one is series object. series data structure. We also have panel, which is for three-dimensional data. So we can deal with multi-dimensional data as well using pandas, but we are going to pay attention to both data frames as well as series data structures in our upcoming sessions. Okay, so that's pretty much all I wanted to discuss with you in this session, and thanks for watching.